derivatives of common cases. Okay, of common cases. Okay, one particular case is y is equal to c, and c is a constant. Then this graph, if I have to plot this graph, I will plot it something like this. This is of the x, this is the y. Okay, this y is equal to constant, so it will be a straight line, right? Here y is equal to c. Okay, and then I can say that change, this particular change of delta x, how can I see the possible values, right? For any change of delta x, delta y is 0, right? For any change of delta x, delta y is 0, right? This is a straight line. Y is equal to constant means basically this is the c intercept, which is a straight line. Now for this particular change of delta x, is there any change in y? There is no change in y, right? Right? It's a straight line. There is no other point of y I can take. Because there is no another point of y I can take. That's why delta y is 0. So what does it mean? Therefore, I can say that dy, change of y with change of x is equal to limit applied when delta x tends to 0 is actually nothing but delta y by delta x. And here we know when delta x is tending to 0, delta y is 0, right? So it becomes 0. So we can say that the rate of change of any constant function is 0. Rate of change or derivative of any function, rate of change or derivative of a constant function is 0. So this is one case we have seen. We'll take another case now. So derivative of a constant function is 0. Remember this, derivative of a constant function is 0. Next case. Next case is, one common case is y is equal to ax. Okay. And the graph of this particular function would be represented as a straight line. This is y is equal to ax graph. So if I take 2 points now, I take this one point here and one point here, and I say this is x1 and this is x2, right? If this is x1, then this will be y1. And what will be the y1? What will be y1? It will be ax, that is the function of, that is how y changes as a function of x, right? So I can write it as a x1, and this x2 also is a function of y, right? So this point here, this change here, I can write this change as y2 is equal to ax2. So now what is delta y? Delta y is nothing but y2 minus y1, and y2 minus y1 is a x2 minus a x1. So I can write this as a common x2 minus x1. What is delta x? Delta x is x2 minus x1. So now what is the slope? Slope of this graph is delta y by delta x, which can be written as a x2 minus x1 divided by x2 minus x1. So this will cancel, you will get a. So, right? So the slope of this graph is nothing but a constant. Slope of this graph or derivative of y is equal to ax is a, right? nothing but derivative of dy by dx is equal to change of y by change of x will be applied here. Delta y by delta x will become equal to a, right? So that means derivative of ax with respect to x is a itself. So let us take another example, another case. The third case we see, we have a common function like y is equal to x square. Okay. So the graph of this function is a parabola. Y is equal to x square. Now if I take 2 points, I take 2 points here. This is x, this is point x, and this is another point. Okay, I'll say that this is the change, right? This is delta x. So this point here will become x plus delta x. So this will become what? This will be y1 is equal to x square, and this one will become y2 is equal to x plus delta x square, x plus delta x the whole square. This is what you're going to get. So delta y is equal to delta y. What is delta y? y2 minus y1, and y2 is x plus delta x the whole square minus this is x, right? X square. So what will you get here? This minus x will cancel. 2. So what will remain here is 2x delta x will remain, and you'll have plus delta x the whole square. So now if you want to find out the slope is delta y by delta x. So delta y is 2x delta x plus delta x square divided by delta x. So delta x will come common. So you will get here 2x plus delta x. This is what you're going to get. So now derivative of y with respect to derivative of x will be slope of y by slope of x when when delta x tends to 0, right? This delta x has to be as small as possible to find the derivative. Rate of change is a small change in x, or this delta x is a small change, right? So you'll get limiting delta x tending to 0 of 2x plus delta x. So you'll get this as 2x because delta x is tending to 0. It's very small minute change of x, that means as close to 0 will become approximately 2x itself, right? So that means derivative of x square by dx turns out to be 2x. I hope this is clear. So this was it about calculus related to differentiation or derivative of various types of functions. We have seen derivative of three types of function. We have seen derivative of a constant with respect to another parameter dx is 0. We have seen derivative of constant times constant time a variable divided by dx. That means the rate of change of this function with dx is actually equal to a constant. And third function we have seen derivative of x square by dx is equal to 2x. So this is what we have seen, and derivative is nothing but dy by dx is nothing but rate of change of y with respect to x, and this is for small changes in x, that means delta x tending to 0 for small changes, right? So with this we can close this part of the session. This is for derivative. So next we will see next aspect. We will see the rules of derivatives in the next video.